Hey, TechKnowStuds. If we're developing some sort of application or has software code that we're writing, then we're going to want to make sure that we are analyzing that for security holes, for security risks, for vulnerabilities. So in this lesson, let's talk about some methods on how to do that. If we're developing code and writing software, then there is potential for a lot of security holes. So we need to make sure that we're doing that correctly. If we're developing some sort of application, then we're working with code and we're executing code. And there might be a few different ways that we can scan this and be able to identify if there's some sort of vulnerabilities. For one, when it comes to application security, we could be doing static analysis. Static analysis is just when we're taking a look at the code and looking for vulnerabilities within the code. And a lot of times it's great because we can see all of the code and identify what is happening within that code. But it's not a perfect solution. There are times when there's vulnerabilities that only show up when it's actually being accessed, when it's actually being executed. And so dynamic analysis is when we actually run the code and we take a look and see if there's vulnerabilities when we're running the code. But the problem with this is that some of the code might not be running at any particular time, and if we don't trigger whatever it is that executes that portion of the code, it'll never get analyzed. So it's important to have both of these. There's also package monitoring that a lot of these different codes and different software use a lot of different packages. And so there are other software components to it. And what we want to do is we want to make sure that those packages that are installed on a computer are monitored as well. Now, typically what would happen with software development is that we would come up with some sort of objective of what we're trying to achieve. And from there, we would architect some sort of design for our code and then develop the code that would meet that design. Now, reverse engineering takes the opposite perspective. What it does is it takes the code and then we analyze the code and then determine what is going to be the response of it. And this is a way to implement some security because we might unintentionally create some security holes. And by reverse engineering, we can better understand what our code is doing and see if there's any holes in it. Another practice that we can do to test out our code is something called fuzz testing or fuzzing. And this idea is that we are going to load up information into our program. It's going to actually be running and we'll load up information into it to see how it responds. And even more specifically, it's weird information. It's information that you typically wouldn't put in there. For instance, let's say in first name is a data set that would expect just normal characters. Same thing with last name, and maybe there's some sort of addresses there's a way that we form addresses and put it in there. But fuzz testing would be put in all sorts of random data into these fields, and whether it is on the front end or maybe we're doing it on the back end, but we're loading it up with just a bunch of strange information that typically wouldn't go into these fields to see how it responds and see if there's any security holes that get developed because of this. Another thing we should be analyzing is the software composition. A lot of times we're going to borrow or use code from other sources. There are a lot of free and open sources out there that we can utilize to make us more efficient when we're developing this code. So what we can do is we could go and find this code and then we incorporate it into our own code. Well, this causes a couple problems. Number one is that this code might be a little bit of unknown. So we're incorporating that into our code, and what is it going to do? How is it going to respond? The other thing is updates could happen to this later on in the future, and are we updating our own code? There is the reverse of this also. Our code that we're developing may call on other sources. So not necessarily integrated into our code, but it's actually calling other programs and other sources. And there's these dependencies. So if our software has some sort of dependencies, what is the holes, what is the vulnerabilities of these dependencies, and what is the vulnerabilities of the communication with these dependencies? There's something called a side channel attack. It's where we observe behavior, and based off of that, we can reverse engineer and figure out what is the processes, what is the coding, how does this set up. A good example of this is side channel attacks happen a lot with like cryptography attacks. And what happens is if we observe this behavior of what's happening with cryptography and can reverse engineer that, now we know exactly what that code is doing, what that cipher is doing, and then perhaps crack that cipher. So this can be problematic with this. And so the same thing is true with maybe some code as you're developing code. Is somebody going to be able to reverse engineer, figure out what your code is doing, and then be able to leverage that, be able to take advantage of maybe some sort of vulnerability with how it's operating. So what we want to do is we just want to look at the side channel and do a side channel analysis to determine, can you reverse engineer this and come up with the code, and can it be used for purposes that an attacker, or would it create a vulnerability essentially on your software?